So I've discovered Noosa's got to be one of the best places for studying rocks. There's like a ridiculously good amount of different varieties of rocks. So what we did was we just normally we go from this end and go to Hell's Gates and back. So we thought we'd do something a little bit more interesting and go from the other side, which is a little bit more of a shorter walk. And has a really good number of rocks. Now, I'm not even talking, we didn't even get to the granites or the shales or all sorts of things we didn't see, but I think you're going to be quite impressed with what you can see. So, just right from the bat, I think the car park's around here. And you walk up to here and then climb up these stairs. And then you've got the beach, and then there's Hell's Gates. Right from the start, if you come to a stream that's perfectly clean, which is this one here, and then it's full of, there's like a dozen shrimp and fish, you're at a pretty nice place, okay? So a lot of arguments for Australia being the best place in the world to live, that's for sure, and Noosa's got to be one of them. All right, so that's the river mouth, and it's pristine, and, it's a creek, I guess, and full of these fish. And shrimp, which are really, really cool. But anyway, so once you're up there, so that's Lion's Head and this is Hell's Gate. What there is these basalt dikes. So you can see that here, these basalt dikes. And so they are resistant to weathering, the basalt. The mineral's not. Some of the crystals inside them. Some of them are, some of them aren't. And then you've got the sandstone here that gets eroded. And so the basalt dikes here sort of prevent erosion, and they also collect the sand, I guess, as it weathers over there. So that's what you got right here. So you see a really nice transition from like sandstone to basalt to sandstone to basalt, and in between you get the metamorphic rocks. So it's brilliant. Like you could literally just walk 20 meters and maybe see everything. And so we'll look at some sandstones first. Well, it's conglomerate, but let's have a look here. So it's all about how big the various stones are and whether they're rounded or granular. So it's 0.2 to 0.6. So I have this really cool hand-me-down lens. So that's 1 centimeter broken up into like 100 segments. And so sandstone's like between here to half the smallest increment. So you can see here, it's definitely smaller than 0.2. And it's definitely larger than half one of these increments. So it's smack bang, and they're all, it's just a really nice quality sandstone. They're very, very similar. Everything's almost the exact same size. And the texture, it's also about texture. So they say it's about the same size as the groove of your finger, which I'm showing here. Which is the groove of your finger is easily in there. And apparently that's what makes it feel rough. So if it feels too smooth, it's probably a siltstone or a mudstone, because the granules are just far too small for our grooves of our fingers to pick up any friction. All right. So I was just watching one geologist talk about that. The reason that they don't, they don't really bring that much equipment. Okay, one of them doesn't bring calcite because, HCl, because the calcite and the quartz, they're just such differences in hardness. You can just scratch one and not the other, so you don't need that either. So they don't bring much in, but I would definitely bring a hand lens in, so you'll see why. So here I can clearly see that there's a consistency, they're granules, and so that matches. All right, now the conglomerate is sort of interesting because the matrix is weathering away. You can see that the more weather-resistant particles are the last to come out. They're sort of bulging out. And then if you grab some sand, this one's got a high amount of magnetite because I put a magnet in there and sucked all the black bits up. But you can see the garnets, which are weather resistant, which we'll come to in a second with the igneous rocks. So the quartz, it looks quite nice under a microscope with the red gems, the garnets, and the black magnetite and the quartz. I'm not sure if they're feldspars or citrine. But that's fine. Could be feldspar. All right. So back now to the basalt. So when you look at the basalts, it just looks like an ordinary grey rock. Technically, it's that's dark, considered black. That one's got at least a little bit of speckling, so that's semi-interesting. So I will look at these and see it's far more interesting once you get the hand lens out. So what's so cool about these ones is they're right on the edge here, so they're really clear. They're not these really mixed up ones here. These 50-50 ones are on the edges. They clearly got olivine, pyroxene, and plagioclase in them, and so it makes it a really good samples of basalt. So if you look in the microscope, all of a sudden you see these green crystals, and then you see the long spindly pyroxene black crystals as well. This is the basalt fine matrix, and then you also see the red garnets as well, and the vesicles. So this all classic basalt. So the really good example. It's hard to get a good example of basalt on this end that shows all the features, and these ones do. They're really not quite nice. And so you can see the olivine and the pyroxene over here, and these weather out quite easily. And you've also got, here we go, garnets as well. All right, and so the olivines weather out quite quick because they're just these single silicon dioxide surrounded by magnesium and iron. It's almost like a salt. Whereas these guys here have these sort of aluminium cross-linking. And so it's far more complex and it's far more weather resistant. And you can see the olivine here. So this one's in the ocean. You can see it's been rounded off and it's all smooth. And it's got these pitted bits. And if you look inside the pitted bits, you can still see leftover bits of olivine in there. And so you can see that the olivine's been weathered out, which is quite cool. And this one here is just the one with the white speckles. So you can still see the garnet and the olivine and the dark fine basalt matrix. And you can even see the pyroxene crystals that have been weathered out. And this one's got the calcium plagioclase. So that's on this side here. So they're all at the very top here. So it's not at one end of the scale, which is quite nice. And so the plagioclase is down here. It's calcium plagioclase, which is hard to see. As I said, it's most of the time you'll see sodium plagioclase. Just to make mention of these people living in these low socioeconomic housing with their heated infinity pools, there is pumice here, and I think that's scoria because it's darker, and that's the pumice because it's lighter, and it's everywhere. But that's floated in from somewhere else. It's not a major feature, most likely from New South Wales, Mount Warning, with all the tuff, and that's just where it lies on the classification. And so moving on, so when you have these dikes, this hot stuff touching the sandstone, then it causes some heat changes. And so what you're going to get here is the quartz. You're going to get the crystals starting to melt here and forming large quartz grains. And it's also much harder as well. And then this one here is sort of like a purplish rock. The colors are not perfectly clear. And then you can start to see quartz band in, and it all becomes almost homogeneous, and it's microcrystalline. So I think this one's chert, very sharp. You could use that to make knives or arrowheads or whatever. So it's good to know your rocks and understand them, because you could actually use that if you're trying to survive out in the wild, I guess. Okay, so I hope you enjoyed that. Highly recommend going out there if you're studying rocks.